Okay, so these are, this one right here is our function, and these two are our derivatives. So the way we found our derivatives is by drawing the function. We take the highest point and the lowest point, and we draw the graph here, and we did little dots to go down here, and we drew again the function. So the way we did this is, because it's going up, it's going down here, and as it's going down here, it's going back up, and so making a curve. And then it goes, doing it again for the second derivative. We looked at the first derivative.
So yeah, we looked at the first derivative, and we did the second one out then. So there.
And to check our work to make sure we were right, we basically counted the local maxes and mins to match up here. So it's like you can see the pattern where it's 2 here, it's 1 here, and almost 0 here. But if you notice, the slope is actually continuous, so it matches up with that. There's no breaks, and it's a continuous slope.
And also, as you can see, the f of x, the original function has it has 2 mins, and the derivative has 1. The third. No.
So let's hear that story you told me you guys created. I thought it was pretty cool.
Yeah. Okay. This is the original function, and it's kind of like, think about okay, we're going up a hill on a roller coaster. You know, when you first get that little thrill and everyone's screaming on a roller coaster and you're going to a safety bar, you know that?
Yeah.
And then, that's kind of like right here when you're going up, and then you get here, and that's when everybody's really screaming. Are y'all on the roller coaster? And then it's more screaming, and then that's when everything blanks out, and then you're screaming yourself, and then you're just like very loud, and then here your stomach, you get that feeling, and then your neck is like this, and then your stomach is hurting really bad, and then you get that gut feeling, and then you get down here, and then you're going back up the hill, and then the ride just continues.
So what happens at those 3 points you have circled? Talk about that in terms of the roller coaster. So at that first one.
Okay, here you begin to decrease in position and relating to the derivative. Yeah, here you're negatively increasing in velocity here.
Mm-hmm.
So
what changes there, I guess, is what I'm asking.
Oh, in the 3?
Yeah, in the first green one. What happens right there? You're changing what?
Position.
Position. How so?
You're decreasing in position.
So I was going up, then I'm going down. So my velocity did what? It went from being what to what? So look at the slope.
Right here, right?
Uh-huh. So it went from being what kind of slope to what kind of slope?
Negative. Positive, negative.
Positive to negative. And when our slope changes from a positive to a negative, our position does what?
Negative.
Mm-hmm. At what point are you at the roller coaster?
You're still here, right?
Uh-huh. But what is it called?
Here.
Mm-hmm. The local what, Jamil? The local max. You're at the highest you're going to get, right? Then what happens at that second green dot? You're at the lowest you're going to get. So your slope goes from what to what?
Negative to positive.
Negative to positive. That's a pretty cool observation, right?
Yes.
So what happens at that red dot again?
That's actually a point of inflection. That's the point, where you feel that, like I said, that check it's going too fast and just like, and it's like
That's when the direction changes.
Yeah.
Great job. So do you want to help us all out and let us know what the other answers are so that people can study when they get home?
So for G5, we have the first derivative as
Hey guys, listen up.
9. So graph 9. For the second derivative of G5, we have graph 6. For G7, the first derivative we have is graph 3. The second derivative, graph 1. And for G3, we have the first derivative as graph 2. And the second derivative as graph 10. And for G10, we have the first derivative as graph 1. The second derivative as graph 8. And finally, for G9, we have the first derivative as graph 4, and the second derivative as graph 2.
Are there any questions or anyone?
Yes, there are.
So does anyone have any questions about any of those that they can answer quickly?
Did everyone get these, or did anyone get to this part of the review package
See,
and go over? You did? Did you get the same answer?
I can't see. Nah. But, no, I'm talking about, I didn't.
You
But,
did?
graph 7 and graph 9, for the second derivative, I don't switch. Like for 1 and 2.
Yeah, I got the same answers.
So for G7, you have what?
For G7, for the second